Go one by one dulu.
Okay, one by one starting from group 1. So, before that, I just open this part. The QR code. There's a picture. Here. I just put on the right side. And then, okay, this part. Group 1. Where's group 1? Okay, here, Daniel. Bismillahirrahmanirrahim. Okay, let's look at Daniel's work. Group 1 coming from slide number practice 3.6. 3.6, where's 3.6? Okay, this part. And if you look at Daniel's work, nampak tak? Can you see it? I hope you can see this, but that 335, no. And we cut something, 3.125 here on the right side, 40, 20, 20, and 2. This is 35, I5. Okay, tak apa. And the question asks you to do Nodal, using Nodal, and to using Nodal to build up this. So if the question asks you to use Nodal, first I will look at your reference point here. And Daniel, there's no reference point here. You should put the reference point first. And then what is the node at this part? The node point here. Any value? Here Daniel put V1, okay. And then here V2, V3. And then there's another part on the right side, which is this part, the 3.125. Okay, make sure everything is in the figure. And then you have 35 I5 on top here. Okay, and the rest, when you being asked using Nodal, you should put the current direction, because when you put current direction, I will understand your equations here. So the first part, what do you think at this part, this part at here? Can you see my yellow color here? This part. What is the node value? Brothers and sisters? How? Brothers and sisters? Afiq, what do you think at that node? What is the value for the node I point just now? Afiq?
Value.
What is the value here? The yellow color here.
I don't know, madam.
Do you know? Okay, I give you some hint. This is
20, madam.
yes,
20.
20 attached to reference point. So this one should be 20. Yes, very good. And then second, okay, this part correct because there's no node attached to no voltage source. Even though this is a voltage source up here, plus here, minus here, and the value is 35 I5, but on your right side here, sekejap, biar saya tutup sikit. Tak boleh nak lukis on the right side. We don't have any reference point at this node, at V3 here. So if you don't have a reference point there, you cannot put the value V1 here as a value of 35 I5. Clear? So far so good, everyone?
Yes.
Yes.
Clear, madam.
Okay, very good. Okay, next. Since you have a reference point down here, okay, this is correct. And then you put I5 over here. Then you can check, do you have your super node or not? If you don't understand what Daniel draw here, so what should you do? You go back to your circuit here. Okay. Do you have a super node? If reference point is here. This is a ground, and you know this is 20, this is V1, V2, and over here this is all V3. Do you have reference point? Maybe I should ask someone here. Anyone? Aisha? Aisha?
Yes.
Do we have a super node? If you look at here.
No.
Why not? Is this a super node? What should we check if you want to have a super node? Super node. What should we check?
Two different variables.
Huh? Come again? Come again, Aisha? To what?
Two unknown
Voltage source.
voltage source and two unknown.
Element connected to voltage source.
Yes, a voltage source, right? Independent source. Either this is a independent source or dependent source. In between what? In between?
Unknown node.
Yes, two unknown nodes.
Two unknown.
Yes, two unknown nodes. Make sure this is unknown, not 10. This is not a super node if this is 10. So make sure this is unknown nodes. So maybe like Vy, Vs, and anything in parallel with it, you need to include as one super node. Make sure you know this because next week will be your quiz. Brothers and sisters. So where is your, is this the yellow part here? Is this a super node?
No.
No, Aisha, make sure you do understand this because I want everyone here clear why I spent 2 weeks for nodal and mesh analysis. 2 weeks or 3 weeks now. Because of this is very important. You're going to repeat this in AC. In AC circuit. This is DC. AC more complicated circuit. So you're going to have it forever. in fact, in your apa panggil tu? In your lab later on, you're going to have it. Inshallah. Okay, now I put it this way. Is this boundary is a super node or not?
Yes.
Yes. Why yes? Who
Ada
say
dua unknown.
Two variables.
yes, because of where is the unknown?
V1 and V3.
Yeah, V1 and V3 are unknown. So you need to draw the boundary around this one, the one I draw. Okay, like this. And do you think that 2 ohms, 1 ohms, and 4 ohms here are all in parallel with 35 I5 here, the voltage source here? Do you think they are in parallel or not? Do you think they are in parallel or not? The 3 resistors. This one, 2 ohms, 1 ohms, and 4 ohms. Maybe I should point someone. Tak ada orang nak jawab. Are you guys concentrate on something else? Macam semuanya macam pening-pening. Amar, okay, Amar. What do you think? This resistor 4 ohms, 1 ohms, and 2 ohms. Are they in parallel with 335 I5 here? The voltage source here? Amar, where are you? Are you there or not? If you didn't respond, maybe I should cancel the attendance. Just say something. Is this 4 ohms, 1 ohms, and 2 ohms are in parallel with 35 I5? Maybe Amal say something in the chat box. Okay, Mak Rosa, okay, you can say something. Yes or no? Are they in parallel or no? Parallel with the voltage dependent source. The voltage dependent source. Voltage source, but this is a dependent. So yes or no? Yes. Why yes? I'm just asking. Why yes? Okay, you can write something. Maybe, yeah. Why yes? Sebab parallel. Why? Okay. Maybe next question to next person. Siapa? Lepas Amar. Alpha. Alpha, what is the condition for parallel circuit? Parallel. What is the parallel circuit?
Parallel lah, madam.
Yes, parallel.
Dia punya hujung dengan hujung bertemu hujung-hujung.
Yes. They are connected together, right? Do we have international student here? Okay. If you have two elements in end to end connected together, so this is a parallel, right? Okay. Can I ask go back to Amar? 2 ohms, 1 ohms, and 4 ohms. Are they in parallel with 35 I5? Do you think the configuration is like this on the right side here? What do you think? Are they connected end to end like this? These 2 ohms? 2 ohms, one end is here, and then 20 here, and then connected to 1, then V2, and then 4, and then V3. There's 3 there. Sekejap, saya tengok. Where's Amar? Pening juga macam ni buka tutup. Okay, let's go to Amar. You need to tell me. Are the two ends connected? All three resistors there, are they connected to 35 I5 voltage source? You need to go back to theory. Everything you need to go back to theory. Are they in parallel or no? If like this, if you look at like this, these 2 ohms and 1 ohms, they have something in between, right? The 20 volt. So what can you tell from this? They are not in parallel or not? Amar? No, right. They are not, because if you want it to be parallel, this is the condition. Go back to the theory. Theory says any elements, when they are connected end to end like this, they are in parallel. So obviously 2 ohms, 1 ohms, and 4 ohms, they are not in parallel. Okay, very good. So next, what should you do? You have a super node. This boundary here, they are super node. Okay, let me erase this. Okay, so when you have a super node like this, you need to, that's why I said it is very important to draw the current direction. In my class, I always do horizontal to the right and vertical to down. Okay, so you just stick whatever you like, but you need to follow passive sign convention. And then look at the boundary here at the supernode. When you have a supernode, you have two equations, KVL and KCL. So the KCL here is that you have a current entering and leaving the boundary. So how many current enters and how many leaving? Okay, how many enters the boundary? I will ask the next student in line. Okay, cepat kira dulu. How many enters and how many leaving? Okay, next.
1 enter, 3 leaving.
Ya betul. Alpha bagus. Okay, good. Ada orang dah selamatkan. 1 enters and 3 leaving. Where's that one enters? This one This is entering and leaving current is this part. 1, 2, 3 and 4. Okay. This is leaving current. Okay. Entering only 1. This part. Okay. So you need to build up equation. Let me check our brother Daniel here. So this one equation for what? Brothers and sisters, always make sure you put what you want to write. Is it a KVL? Is it a KCL? Anything. Where you want to build this? At Supermesh? Or at V1 or V2? So you need to be clear. Okay, like maybe at node V1 here. Where is node V1? Okay, here. Here, if you put it like this, I know that you are not saying that you have a super node. So straight away I will say wrong. And I will tend not to look at your answer. How many students do I have? I have 2 sections and I have more than 100 students. Do you think I have time to look at your answer if you do it wrong like this? So please pity me and please pity yourself also. Yes, I certainly will look at your answer, but the thing is try your best to make others easy. Okay, so let me check your work. This is V1 over 20. Okay, but V1 minus 20 over 2 here, yes. Tapi this is wrong because you have, kejap this is apa, 13. What is this, 13? Mana kejap. 13. 13 coming from where? Maybe this one, right? Kejap. This one I'm not clear. This is maybe wrong. So this is wrong. This one and this one, yes, because this is going out. This is going out. So obviously this is wrong. It should be at the super mesh. Super mesh, but super node. Super node is at here. So this number 1 wrong. The first part here, what is this first part? V3 minus V2. It is also unclear. This one unclear. Okay, tak apa. Do you have other suggestion for V2? Let me check at V2 here. Yes, 20 minus. This is KCL at V2, tapi V2 divide by 40, yes, correct. And then V2 minus V3 over 4, correct. And then V2 minus 20 over 1. Yes, if you put it the direction that way. So this is correct. But if you want to follow the direction I have over here, then this is 20 minus V2 over 1 equal to V2 minus V3 over 4 plus V2 divided by 40. The equation here and here, they are both correct. Okay, so for your answer like this, I will give marks on your figure, but I will reduce some marks because of your there's no super node. And then the equation here are wrong because there's no equation for super node. And also this part also, is it wrong? 20 minus, yeah, this is also wrong because VA, where is VA? Mana VA? V delta, I think. 20 minus V2. No. It's supposed to be V delta here is because because your current direction is the other way, right? Because if you look at the resistor here, this is 1 ohm, and then the plus sign here, V delta here, and this is V2, this is 20. So if you follow the passive sign convention, current direction will be to the right side. So what should you do? If you put the direction the other way around, in opposite direction, yes, you may do that, but you will have a negative outside. Because your current direction, I think you put it this way. So V2 minus 20, but you have a negative outside. Okay, because why? Because this is a negative. You are not following the passive sign convention for V5 here. V delta. So if you follow the current direction of, I change the color, this part, this arrow, and following this, so V delta will be equal to 20 minus V2. Straight away you're going to have this. And class, do you need to divide by 1? Here, the resistor. Do you need to divide by 1, brothers and sisters? Iman?
No.
Siapa jawab tadi? Afiq. Do you need to divide by 1?
No, madam. I think because you want to for current.
Yes, that one for current, right? Current is equal to voltage over R. And we don't need the resistor because we want to find only voltage. So only voltage difference. Okay, very good. All right. Do we have other suggestion from group 1? Ada tak daripada group 1? Anyone who submitted more or less like that? Okay, Arif. Let me check. Okay, kurang-kurangnya Arif, we do have super node here, yes. But for your figure, please make sure you have this, yes, reference point, and then the boundary for your super node. Okay, that's good. You have the current direction, very good. And then you have the this node, this, and this, and this. So this is full marks. No, not full mark because you forget the boundary of your super node. So maybe this is 1 marks. And then KCL at super node. Okay, let me check. This is V1 divided by 20. Yes, V1 minus 20. Yes, and then V2. Where's V2? Okay, V2. This is not sure. V2 minus V3. This part. Is this the same equation or different? Arif? Is these two the same equation, continue, or you have it different equation on the right side?
I made a mistake. I thought the resistors were parallel with the voltage source.
Oh, okay. Maybe this group assume that they are in parallel, right? Okay then. Okay, tak apa. So this part, there are different part, and then just continue. Okay, V1 minus V1 divided by 20, yes, and then V1 minus 20, yes, and then you have a V2 minus V3. But this is equal. This is equal. V2 minus V3 over 4, not 40, over 4. Is it 40 or 4? I think 4. Okay, 4. And then at here you have another equation which is V3 divided by 80. and then plus 3.125 V5. Because why? Because over here going out, going out, going out, and going out. So you should plus everything. That 4 on the right side. Maybe I should point with this color. 1, 2, 3, and 4. So you have 1, 2, 3, and 4. And then this is equal to the entering. This is entering. Okay. Okay, good. And then that one is for KCL at the super node. Very good. And then what is your KVL? KVL at super node. Arif suggested to have higher in polarity, which is a plus here, which is V1, minus with low in polarity, minus here. So you have a V3 equal to 35I5. Yes, very good. This is correct. Kejap, sorry, silap. This is correct. Okay, what is I5? I5 is at the middle here. So I5 should be equal to V2 minus 0 because this is reference point 0 divided by 40. So this is correct. And then other part is that you need to take out the middle part here, this area, which is at V2. V2. So where's your V2 equation? No equation. But you can refer to your to the previous work. But it is 20 minus 20 minus V2 divided by 1. This is going to the right and then equal to V2 over 40 plus V2 minus V3 over 4. Okay. And then you rearrange, you have 3 equations. This is number 1, this is number 2, and the last one here, number 3. And if you rearrange that, you will get something like this. Section 1. Okay, if you rearrange, you have 2 supernode value here, supernode here, and then you have KCL at V2, and then you do your quadratic or matrices, and you will get this V1, V2, and V3 value. But the question asks you to find what? Power, right? Power developed by the 20 volt source. So even though you have this 10 volt, but if you look at the question here, this is 20 volt in the middle, right? Draw. The 20 volt is here. And you know that the voltage is 20 volt. But what is the current at this side? You can draw the current. Maybe the current is, if you follow passive sign convention, it says that what? Current is leaving a positive or negative for active mode, active element. Brothers and sisters?
Positive.
Yes, it leaves the positive here. So you should just follow this, and then you have a current, this current, and this current. So build KCL at this point, you have V1 minus 20 divided by 2, and then equal, plus this current, maybe I note here, I note, and then equal to 20 minus V2 divided by 1. Okay, and then you will get I note, because V1 you already know, coming from your answer, V1 and V2, this part and this part, and then you will get the current direction I note. And then because of you're going to find what the current here, this is done, but you're going to find IV, right? Power equal to IV. And since this is entering a negative, you put a negative sign. And then you have I naught. And then you have a V. V is 20. So you will get the power in negative. What is negative tells you? Power is absorbed or dissipated? Which one?
Dissipated.
Dissipated or delivered, right? Okay. So power is delivered. All right, good. So that's how you find your power. Okay, inshallah. Okay, so far, is it clear or still confused?
Clear, Madam.
Okay, inshallah. All right, very good. Next, we go to our next. This one return. This one return. Okay, group number 2. Mana group number 2? Number 2. Siapa group number 2? Who's in group number 2? Anyone? Yeah. Zaidul. Zaidul. Okay. Group number 2, you need to use mesh, right? Use mesh to answer your question. Okay, brothers and sisters, what will I check if the question asks you to use mesh? From the figure, what should I check?
Loop.
Yes, loops, right? Loops in all closed loop. So please do not forget to draw the loops. Okay, number 2, what should I check?
Boundaries.
Yes, boundaries. Boundaries are what?
Super mesh.
Super
Superman.
mesh.
Super mesh, okay? So make sure if you do have, then you draw that. So yeah, you draw the boundary. Where is that boundary? What is a super mesh condition? What is super mesh condition? You have what?
Current source between two closed loops.
Current source.
Current source in between what?
To close loop.
Two closed loop. Yes, very good. So if this is a closed loop and then a current source in between there, whether this is dependent or independent, as long this is a current source, then you have a super mesh. What if you have something in series? What should you do? Maybe some element in series with this current source and in between two loops, two closed loop. Do you think that this is a super mesh or not?
Include it in the boundary.
Yeah, this is a super mesh. You need to include all here. Okay, very good. And okay, all right. Now, where is your super mesh? Over here, right? You need to draw that. So, including the current direction. So, this is your current direction. Okay, now I will look at your answer. Do you have it in your answer? Even though you didn't put like this, yes, sometimes I will just accept. Unless you have all A student in the class, then I will reduce your marks over here. If I think, if I look at all your answer script that you have less A student, then I will just give full marks on your figure just because of you have the figure. So please do not omit your figures. Okay, so KCL here you have, this is, what is this one? You have a 11 milli, but the same direction minus the opposite direction. So because this one, I'm not sure which one is which one. Maybe I just put name. I want I2, I3 and I4. Betul tak? Nanti So, besar juga macam ni. Because I want to draw according to your value here. Pening. So this one I1. It's supposed to be I1 here. Minus I4. Maybe he put this one as I1. Is it? Okay, Zaidul. cepat. Zaidul Abrar. Which one is your I1? I1 loops. Brother Zaidul? Huh?
At 20 volt.
At 20 volt. Okay, this is correct. Which one is I2?
Right.
On just next to this. Okay, I2. And then I3?
Right.
Next to the I2. Okay then. And then I4 will be at the top right there. Is it?
Yes.
Okay. All right. And then if I look at like this, then I2 minus with I4 equal to 11. I2 minus I4 equal to 11 milli. So over here you have I1 and I2 seems right, but this is not right, incorrect. Okay, and then this is KCL at super mesh. Write down which one you target. And then second, KVL. KVL at, maybe this is also super mesh. Okay, so if you start your, is it KVL at super mesh or where, Zaidul? On the right side here. KVL, where is this one? At loop I1? Is it loop I1?
Actually, I don't really understand.
Okay.
Sorry.
Tak apa. So I assume you put it KVL at I1. I1 is here. So what should you do? Maybe you start from negative here. So negative 20. I can see the negative 20. And then you have 25K. Entering current should have a positive. So you have 25K there. Okay. With this loop. This loop is the loop I1, right? I1 here. Okay, so you have I1 here. This is 25K. Since there's only one current at this 25 ohms, 25 kilo ohms, then you should put just only one. This is correct. And then you have 250 ohms. 250 ohms here shares in between these two loops, right? So you should target first because currently you are focusing on this loop. So what should you do? The current here minus with the opposite current shares with this 250 ohms. So you have 0.25 kilo here, yes. But for this part, you have a I1 minus with the opposite, I2. Okay, minus 20. So you have, this is correct. Only this part not right. The I2 part is not correct. Okay, maybe because you don't understand the mesh analysis. Okay, but make sure you check my video, not check. You do the apa panggil? Revision, yes, very good. Revision. Okay.
Alright, madam.
Okay, this one done. This is for I1. This one for super mesh. But you need another one, which is the KVL at super mesh. So what is the KVL at super mesh? Maybe you start from 500 ohms here. So 500 ohms is a passive element, so you should have a positive. So this is a 500 ohms. What is this current? I4, right? So this is I4. And then the current is moving this way. And you have a 1 kilo. Entering a passive element should have a plus. So that's why you have plus here. and 1 kilo. Since 1 kilo is sharing in between these two, so you should focus this boundary first. So this is I2, right? I2 minus the opposite, which is I3. And then the current is entering 250. You have a plus 250. And you are focusing in I2 first. So I2 minus with the one 250 ohms shares with. So you have a I1. Okay. And then you go back to the 500 ohms. So you close it with 0, equal to 0. Then you will get the equation for KVL at super mesh. So far, so good. Please do understand in this, because I don't want you to lose mark, because this is to me nodal and mesh are very easy lah, inshallah. Easy because you don't have any macam hidden agenda. There's no like apa kita panggil tu a short path or anything like the one I give you in the assignment. Okay, it's very straightforward. All right. Is the methods only you need to focus on the calculation. If you do your calculation wrong, then everything else wrong. Like if you give me this figure, you get 1.5 already. And then if you give me this equation, you get 1.5. And this one 1.5. And this one 1.5. How many marks you secure here? Like this is 3, 6 already. 6. And then the final answer, maybe I will give you like, maybe if you have 3 things to find, I1, I2, and I3, this is another 1.5. So look how generous I am, right? Okay. So if you get everything else correct at the equations only and figure, you already secure 6 marks. And let's say your final answer is wrong. Minus 1.5, right? So you have like here 6 over 7.5 already. Look at the correct equation first. Okay, and then the figure. And then yeah, you can get almost full marks. But make sure you give me the final answer correct. And then you get 7.5 total of these marks. Okay, alhamdulillah. We are at 11. Okay, can we move to group 3? Do you have any question? The answer for that question is, do I have? Yeah. The answer is this one. I1 is 1 milli, I4 25 milli, I5 10 milli, because I put the numbering is like this: I1, I4, I3, and I5. But what is I2 equal to in the middle here? I2 shares, I2 is moving through 250 ohms. So it shares in between two loops, I1 and I4. So it should be the same current direction of I2 minus with the opposite current direction. So I1 minus I4 equal to I2. And then you're going to find I3. I3 is this part. So just follow this. And I1 also just follow this one. So you will get straightforward answer. And there's no hidden agenda, like I said. You have a I3 there. Okay. Brothers and sisters, semua rasa macam, are you guys okay? Sugul?
Yeah. Okay.
Okay.
Baru bangun tidur.
Okay.
Masya Allah.
Fokus ni tu.
Okay, good. At least you have your, please make sure you had your breakfast before coming to the class. Because sometimes you will upset your day because of no breakfast. Betul ke tak? Ke puasa semua?
No, madam.
Kalau memang ada masalah tu, let me know. Jangan puasa all the time. Okay.
Hari ni
Okay.
hari Rabu je.
Masya Allah. Mana tahu seminggu straight. Okay. This is group number 3, right? Saya ni main buka je. Hafizuddin, are you in group 3? Yes, group 3. Okay. Group 3, they ask you to find dan mesh. Mesh. Okay. Like this one. Yes, I can see that you apply mesh. This is correct, and correct. Tapi tak nampak lah, Hafiz. This figure betul nampak, tapi inside this one, maybe IA. Tak apa.
IA, IVC tu. I see that IA, IB, IC.
This is IC, this is IB.
Yeah.
Okay. Alright. And then I will look at your super mesh. Is this your super mesh, Hafiz? What is a super mesh boundary? Maybe you are unclear. Super mesh boundary is the one, this is a current source, right? Current source shares in between two closed loop, right? So where is that two closed loop? You just focus on the closed loop. Okay, let me draw that. This is the first closed loop. First, and this is a second, right? So only this part. Ada somebody baru masuk. Okay. Okay, so where's the boundary? The one I color yellow. Okay, very good. Okay, let me see. KVL at super mesh. This is 10. IA, yeah, and then 50. Maybe your boundary is wrong. You go to this side, right? So this is wrong, and this is also wrong. So what should you continue? It should be this way, not this part. So you have a 50 IC minus IB. Okay, make sure this is your direction. It's better to have the same current direction. If you put it in wrong current direction, let's say this is clockwise and another one counterclockwise, then you need to plus lah in the middle. There are some certain rules that you need to follow. Okay, and then you have a plus here because current is entering a passive element here, which is 25 ohms there. And then it shares between IA and IB. So IA, the one we focus first, minus with the opposite. And close this part, you have 0. Okay, this is wrong. Okay, KCL at super mesh. So the same current direction as your current source here, which is the IC, minus with the opposite, which is IA. So IC minus IA, you get this. Yes, very good. Or because if you don't get what I suggest, maybe you can apply the KCL at this point like Hafiz did here. So this is IA. Oops. This is IA, and this part is your IC, and this is 4.3 ID. So IA plus 4.3 ID equal to IC. So this is correct, like this part. Okay. If you have another way, which is the same current direction of your current source, which is IC, minus with opposite IA minus IA equal to 4.3 ID. It should be the same answer as your for both equations here. Is it same or not? Is it same? Brothers and sisters, is this two same or not?
Yes.
Yes.
Sometimes I need your response because sometimes I was kicked out from the Google Meet. So I need your response.
Okay, madam.
Okay, IB, for IB here, yes, you have a minus 200 and then you have a 25 ohms. IB minus IE, yes, correct. And then 50, IB minus IC, yes, correct. But you forget this part, 10 ohms. So over here plus 10 IB equal to 0. Okay. Okay, make sure everything correct and then you will get the answer. What is IA equal to? IA is equal to this loop, yes. IB equal to this loop, yes, correct. But what is ID? ID is equal to IB minus IE. And then IE is equal to IB minus IC. Okay, these two. So you will get the answer. I don't have the final answer, but you, because your calculation here is wrong and this is also wrong. The equations are wrong. So redo this thing in your groups and then compare with your friends. Do you get the same answer or not? This one should be correct if your equation is correct. Okay. So far so good, or do you have any question?
No, so far.
Yes.
If we write the equation in matrix like that and immediately write the answer, do we lose any marks?
If the equations are wrong, then you will lose marks. Do you?
No lose mark.
There's no. I will check on your figure. That's why I say, figure is very important. Even though you have it wrong here, and maybe your second equation is also wrong, then I will still give marks on your figure. And what else? Okay. What else? Because sometimes if you give me this one, this part like this, if this is correct, I will give marks on this one, and this one also one. Some any equation that is correct, then I will give marks on that. Okay, so make sure you do write me in forms of this form, because sometimes you put it in terms of value. If your value is wrong, then I will say automatically this everything else wrong. So try your best to be careful. Be careful on what you write for your equations. Okay. Any question?
No.
No, Alhamdulillah. Okay, number 3 done. Number 4. 3 done. Number 4. Group number 4 here, Aisha. Okay, group number 4, you need to use Nodal. And if you're going to use Nodal, then I will check. What should I check? Try to guess. What I'm going to check. Can you guess?
Current flow.
Current flow, okay. Another one? Yes.
Boundaries.
Boundary.
Unknown variable.
This one.
Reference.
Yeah, reference point.
Reference.
And then the node, right? This node. Okay. And then the boundary. What is that boundary? What boundary is that?
Super node.
Yeah, super node. Do you have a super node here? Do we have or not? Let me clear this. Maybe you cannot see. Do we have a super node?
Yes.
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 Where?
C.
C,
AB.
A, B. In between A and B, right?
A between A and B.
Yes, you can draw like this. Or if you have highlighter, then you can do the boundary like this. Okay. Right. Now, this is a boundary for your supernode. And when you have a supernode, you have two equations. You have a KCL and KVL. Always make sure you have it in your heart that if you have a any super, you have a KCL and KVL. Supernode or super mesh. Okay, done. And then if you look at the question, this is 3.15 from the Nodal. 3.15. And this value are with S, right? Simon. Ataupun Miho. So if you have that, it's either you change your the value to 1/3 because the transconductance is equal to 1/a reciprocal of your resistor, right? So you can do it like this, or you can just maintain the S value, okay, or the Miho value, Siemens or value, or Ohm's value, Miho, sorry. So if you have that, okay, you can put it like this, and then okay, check. I think Aisha didn't realize, or maybe didn't realize there's a supernode, so it should be the KCL at the supernode. So the current direction is this way, and this way, and this way, leaving or entering the boundary. So anything attached to the boundary, this is a boundary, you need to include that. Okay, so this is 2 amps. Obviously, I think this is wrong because of, kejap, betul tak ni? I note, where is I note? And then I1. Tak, okay, bukan. This is not I2 Aisha. It should be 2 amps. Okay, so this one should be KCL at the super node. And you have this, how many current entering a super node? Aisha?
All living.
All living, yes, very good. Living, and living. So you have 4 there. So make sure you have 4. You have 2 plus what? This one, this is A minus 0. A minus 0 over 1/6, right? And then you have B minus 0 over 1/5. And then you have B minus C over 1/3 equal to 0. You can put it this way, or because Aisha put A, B, and C, so you just maintain it like that. And then the second equation is KVL at supernode. And yes, Aisha have this one, A minus B equal to 10. This is 10 volt. So this is correct. But try your best to maintain the apa panggil, the unknown you write down. If you put it as a VA, then VA. Okay. If you put it at maybe B or C, then you maintain as a B or C. So this is correct. This is 1.5. And then this one is a 1 because there's no boundary there. And then you have another junction. What is your aim? Aim for your nodal analysis? to find the unknown
variable.
unknown node. So there's one more, which is at the C part.
Node.
So you have over here, do you have the equation here? Data. Let me check here. Kan sini. This is 4. This is 4 M's. Okay. So you have another one over there. 1/3. Where is that equation? Tak ada. Okay, tak ada. So KCL at C. Maybe I put VC there. So you have a B. This is entering. And this is also, this is entering, this is entering, this is also enters. So you have 4 plus 2 plus VB minus VC over 1/3. Go to 0. This one clear or not? Anyone here is not clear what I just did here? It's actually coming from this side, this side, and this side.
Madam, I think I did the KCL at VC, but I don't know whether it's true or not. It's correct or not. At the bottom,
Come again. Sorry.
I did the KCL at node C.
Okay, kat mana? Yang mana satu?
Bawah yang
This one.
yeah.
Okay.
No.
Atas.
I did write the KCL at node C.
Node C, right? But which one?
Belah kiri.
Belah kiri. Okay, this one.
Bawah yang dekat line yang KVL at super node yang madam tanda tu. Yang the right
side. Oh ni. Is it this one?
Bukan. Bawah sikit.
Itulah kena tuliskan.
KVL at super node.
Here.
Yeah, that one. Yeah.
Dah tulis dah pun. Masya Allah. Okay. KCL at node C. Okay. Baru saya nampak. Okay. Alhamdulillah. This is 4, 2 and VB minus VC. Yes. Correct. Thank you. Macam mana ni kalau dalam exam saya tak nampak? Okay. Usually I will look at your final answer also. Sometimes this is correct. Because usually student will give some gaps in between, like this part, there's some gaps. And this one, there's no introduction. You need to give some introduction, else I will take it as one paragraph. Okay, done. You have all 3. So you can answer, I think. This is the first equation. Okay, number 1. And then you have another equation here. Second equation. And the third equation here. All these 3. And then you rearrange. Since number 1 is wrong. Is it wrong? This is correct. Yes, correct. Okay. This one correct. So I just remove this one. So this is number 1, number 2, number 3. Okay. Maybe your final answer also correct because of your everything else correct. Inshallah. Tapi this one your final answer. Brothers and sisters, please do not put in fraction point. Fraction form or ratio form. 3 to 4 divided by 11. No, put it in decimal point. Okay. Okay, that's good.
Okay, madam.
And with prefix if you have, and also unit. Okay, inshallah. Okay, now do we still have time? Yes, we do have time. Number 4. Done. Okay, 9. Group number 9. Mana group number 9? Tak nampak. Oh, here. Wafat. Okay, Wafak group, they need to use mesh. Okay. Do you think that we have super mesh? Yes. Wafak put a super mesh here. Sorry, patutnya highlight. Yes, tapi there's no boundary, right? Where is that boundary? What do you think?
Between I3 and I2.
At I2 and I3. And then you put the current direction. I just follow the current direction Wafak did here. Okay, very good. And then you have this, let's mark for the imaginary loops. Then at I1 here, macam ni lah. You try your best to put like Wafak did. This is one paragraph, this is second, and this is third. So it's clear. And also you have the figure. Okay, number 1 at I1, so you have 2 I1, correct, plus 90, plus 4, I1 minus I2, and then you have 1 into I1 minus I3. Yes, this is correct. And then KVL at super mesh. KVL at super mesh, you start with 5 I3. Okay, good. Start from here. Then this is a plus. You have 5 I3. And then you have 1 there. Shares between I3 and I1. So I3 minus I1. So this 4 shares between I2 and I1. Yes. And then you have 180. And close with 0. Make sure you always close all the loops equal to 0. Because else you will get the wrong answer. Okay, KCL and super mesh. You have a 45. Okay, good. The same current direction, which is I2, minus with opposite. Yes, very good. Then I think the rest is correct because you have the all equations correct. Inshallah. Do you compare this with your group mates, Wafak?
Yes, madam.
Yes. Okay, very good. And another question I'm going to check is your I note, because the question asks you I note. So I note is equal to the same current direction I3 minus I1. Minus I1. So you have I3 minus I1 equal to I note. Make sure this is not capital letter. It's supposed to be a small letter because of in DC form. Later on, we're going to have an AC. AC, we have all capital letters. Okay? Okay, inshallah. Okay, very good. Group number 10. Number 10, you're going to use mesh. Alamak. Zal, mana figure? Figure, no figure? Okay, we look at Haikal. Sekejap. Do you write something in the chat box? No. Okay. Sama. Haikal pun tak ada figure. It's quite difficult to analyze your figure, your paper if you don't have figure. Okay, kurang seorang dia. Okay, let's see the okay, mesh. Do we have a super mesh here? We use mesh analysis to find I1, I2, and I3. Yes, because current source is in the middle. And then you have all loops there. So you will get full marks here. Okay, next, you're going to build up KVL at super mesh. Starting from 2. So this is 2, betul. This is 8, I2. Then you have a plus to V node. And then 4, I3 minus I1. Correct. and close with equal to 0. And then I will see KCL at super mesh, which is 3 equal to I3 minus I2. Yes, correct. And then you have the last loop. KVL at I1 minus 12, 2 into I1 minus I2, 4 into I1 minus I3. Yes, correct. And then what is V naught? Brothers and sisters, what is V naught equal to? Can you guess? What do you think? Let me check. Ada tak? Can you guess what is V naught? V naught is here. If you apply Ohm's law, what is V naught?
-2.
-2. Okay. If you want to follow passive sign convention, yes, go ahead. Then the current direction will be this way, right? And then you have current is entering 2 ohms. That's why you have a plus here. And then you have these 2 ohms shares in between 2 loops, I1 and I2. So what is the current if you follow this current direction? I1 minus I2, right? And then into 2. 2 is the resistor. Do you get what I mean? If you stay confused, you can draw this. This is I1, okay? And then this one is your I2. And this is the current direction going down, right? So KCL at this point, you have a I1 equal to I2 plus this I that you're going to find. So you rearrange, I is equal to I1 minus I2. So this is what I mean by the current here. Okay. So far so good. And then you need to into 2, multiply by 2. Because why? You're going to find V naught. Where is V naught? At here. Is it clear? And then you apply. When you found your I1 and I2, okay, I1 and I2 here, then you just apply that I1 minus I2 3.5 minus I2 into 2, and then you get V naught. Is it clear or not? Because because sometimes this question here is very straightforward. They just want you to have I1, I2, and I3. But sometimes in our final, or because you don't have midterm, right? You have a final. Sometimes they will ask you on this part. Purposely, they will ask you on that. So how to find that? You're going to apply the Ohm's law or any rules that you learned so far from your circuit class, inshallah. Okay, I think that one is straightforward. Okay, the last group, 11. Any volunteer from group 11? If you want me to check yours. Okay, I will just pick. Kalau tak ada, right. Okay, wow. Okay. The question asks you to find using mesh. So, like I said, I'm going to check imaginary current. Okay, right, have there. And then, do you have super mesh? If by looking at this, I assume that, right, it says no. So, yes, there is no super mesh because only voltage source here. Okay. And then, second, I'm going to check on your calculation. Right, please make sure you put a KVL at where? Maybe because this is 120. I'm not sure, you focus in? Maybe I1 first. Okay, I1. So, and you enter this one first. So this is a plus, yes. And then 30 I1, yes. And 10 I1 minus I2, yes. But what is wrong in this equation? Anyone can figure out?
Equal to 0.
That's not equal to 0. What should I do if that's not equal to 0? Should I skip this one and then I accept this one?
Yes.
Yes, no. Okay. Okay, since everyone agrees that, okay, I will accept this. If the equations is correct. Okay, very good. KVL. Add, maybe this is I2. Bukan. This is I3. Okay. Then you have a negative 120, very good. And then 10 I3 minus I2 and 30 I3. Yes, this is correct. And this is KVL at I3. At I2. So 30 I2, and then plus 10 I2 minus I3, and then plus 10 I2 minus I1. Yes, this is correct. And I hope you get the answer correct. Do you compare with your friends here? Right?
Yes, madam.
Yes, okay. Everyone gets the same answer, but make sure this is with units. Okay?
Okay.
Okay. All right. Please prepare for our next class will be quiz, inshallah. When is your midterm break?
22. 21st.
21st. Oh, another
Until what? Until when?
until when? Only chapter 3 for our quiz.
Oh, okay, madam.
Is it okay?
On Monday.
Yes, the first day, inshallah. Kalau saya, if I'm ready with your question, then we will have your quiz.
Adam.
Yes.
Adam.
Yes.
Can I get the QR code?
Oh. Yeah. This one. Okay, for your attendance, please check this one. QR code this one, and then you fill up. Okay, do you have any questions before we end our class? It's already next week. Next week. Monday, inshallah. Because I think you guys already master in mesh and nodal. Because we have like how many? 11 examples, right?
Oh, so masuk mesh and nodal je lah.
Yeah, chapter 3 only.
Okay, thank you.
Is it okay, or do you have any bantahan? Okay, so we end our class with tasbih kafara and surat al-as. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Wal 'asr innal